of changing the 3 terms that I started with into 4 terms and then factor by grouping, blah, blah, blah. So this creates all the situation. The leading coefficient not being 1. And now we reviewed half of trigonometry, really, here, with all this. Where to find what, how to read this table, how to apply it, and how to write solutions, the general solutions, including going around the circle in both directions. So that's why it took that long. Okay. Any questions about this? You really have to review this. Oh, yes, of course. When I touch that cable, I'm sorry. Thank you. Sorry about that. So I strongly recommend watch the other videos or watch this several times because I'm going to post it after class. Okay, anything else you would like from here?
Can you do one of problems 3?
Yes. So tell me which one from 3. You want the rational equation, the inequality. This is linear. This is straightforward, but we can do any of this. Would you just tell me what you want?
First one, 3a.
This one, the 16x cubed equals x. So remember when we looked at the previous equation, I said it is a trigonometric equation, but also it's a quadratic. It's quadratic in form. I was able to solve it as a quadratic equation, right? So this is not just trigonometric trig equation, but also quadratic. So being able to identify correctly is the starting point, right? So here I have to look at this and say, okay, what is this all about? So what type of equation is it?
It's a quadratic.
You cannot say quadratic because quadratic means what degree?
Oh, 2.
2. So it's not a polynomial of degree 2. So then what is it? A polynomial degree?
3.
Yes. So it's a polynomial equation and degree 3. How many solutions will I have to look for?
3.
Absolutely. Degree 3, who said that?
Sean.
Thank you. Degree 3 absolutely means 3 solutions. Absolutely mandatory, real, imaginary, I don't care. Good. How do we start? This is not quadratic, it's polynomial, but the starting point is pretty similar. Yes, we have to set it equal to 0. Excellent. What now?
We factor out an x.
Sorry, say it again.
We factor out an x.
Very good, awesome. 16x squared minus 1 equals 0. Good. What do I do with this? And the answer is this. That's why we reviewed these 3. Can anyone tell us how to write it?
Is it 4x minus 1, 4x plus 1?
Excellent, thank you, Brian. Good. How many solutions we expect again?
3.
Very good. Can anyone give us those 3 solutions?
It's x equals 0.
Excellent.
1 over 4 and
Great job. Thank you very much. Who was that? Natalie? Thank you.
yeah.
Great job. Good. Moving on. Anything else?
Can you go over 3C?
This one?
3C. Yeah.
Okay.
Yeah, with fractions.
Okay. So negative 3/5 x plus 3 equals 1/2 x minus 5. One thing I would like to say, and I'm going to change the camera for 1 second so you can see me. In my class, if you really, really want to study, you will learn everything. You will learn algebra, you'll learn calculus, you'll learn trigonometry. But you really have to be focused and stay focused. And you will be very happy. And you will acquire a lot of algebra skills moving forward to Calc 2 and beyond. And you're going to be very happy. So please watch my videos and other videos if you'd like. There are other videos in modules I can show you from other people in those modules, not in the modules of the that I showed you with the entire course. No, those are only my own videos. But in other modules that I showed you, module 1 and 0, you can always find other videos. So please do that. Sorry, I'll get back. So what I was going to say about this, never be afraid of fractions. It's so easy to deal with them. This denominator is 5, this denominator is 1, this denominator is 2, this denominator is 1. Can anyone give us the least common multiple, also called least common denominator?
Would it be 10?
Yes. Just multiply everything by 10. When I multiply this by 10, what do I get? Remember, it's negative 3/5 times 10. We always simplify first and then multiply. So this is negative 6x. I have to multiply the next term. I cannot miss any term. I cannot pick and choose. When I multiply this by 10, what do I get?
5x.
And I multiply this by 10, what do I get?
50.
Please understand, there is no need to write plus, plus, minus, minus, all sorts. You are moving this term to this side. I prefer keeping the variable on the left, and I move this term to the other side. All I need to do is change their sign. This becomes negative, so then I have negative 11x. This becomes negative, so I get negative 80. And when I divide, I get 80 over 11. Again, try to move away from writing minus 5x, minus 5x, minus 30, minus 30. There is no need. You move one term to the other side, it's positive here, it becomes negative here. You move this term to the other side, it's positive here, it becomes negative there. Done. Any questions? So again, please don't be afraid of fractions. You can always manipulate the expression quite easily.
Can you do
Anything?
number 5?
Number 5. Awesome. I was going to do that even if you didn't, but you were way ahead of me. Excellent. Okay, so we are looking at, which page am I on? I think I'm on 6. Yeah, I'm on 6. Okay. So this is what is called a piecewise defined function. Piecewise defined function. I'm going to copy it here. Is defined by 3 pieces. Okay. When I am asked to do graph a piecewise defined function like this one, defined by 3 different functions, of course they will not overlap. It's not going to, the graph will never look like this. This is not a function. By the vertical line test, it's not a function. So be very careful. If you show something in which the graphs overlap like this, it's totally wrong. You can start from scratch. Why? Because this is to the left of 0. This is only between 0 and 2. And this is to the right of 4. They could never, ever overlap. They are defined on different values of x. They will never overlap. Okay. So every time I'm asked to graph a function, piecewise or otherwise, doesn't matter. When I'm asked to graph a function, first thing I have to determine is anyone.
Which function
Say it again.
which function is going to go?
There are 3 different functions. So when we graph a function, we always have to start with the domain. That is the key, because I have no idea where to start, what values to put in. So that's number 1. And number 2, I have to create a table of ordered pairs. And only in step 3 I graph. So these are the 3 steps that I have to perform, no matter what type of function I'm given to graph. Okay, so let's talk a little bit now about the interval notation. I would like to present this. There is nothing else. I don't have anything else. How do I present this in interval notation?
So that would be parentheses, infinite, negative infinity, comma, and 0, and bracket.
Great job. Done. Can anyone else tell us the interval notation for this?
It would be bracket
Careful.
0.
There are no equal symbols.
Oh no, sorry, comma, or sorry, parentheses. 0, comma 2,
Very good.
comma. I mean parentheses.
Excellent. Somebody else for this last one?
Say 4 to infinity. And then the other one is like a brick type of print. I don't know what it's called. And then the
Bracket.
bracket. Alright.
No worries. No worries.
And then the parentheses.
Very good. Awesome. Good. So from here, can you identify the domain of this function? Simply looking at these. What is the domain?
A negative infinity and 0.
Careful. There is no gap here.
Negative infinity to infinity.
To 2. Union.
Then 4.
Very good.
Bracket 4 to infinity.
Good. So we are done with this. We are continuing with the table now. I have to have negative infinity, infinity. I have to have 2 in the table. 0 is a must, always. I have to have 2, and I have to have 4. Are you with me so far? Did anyone get lost? Okay, I got one yes, and everybody else is not saying anything, so I'm not sure. Are you with me? Okay. Perfect. Next. At 0, it happens to be an important value, but 0 will be always in every table, even if the function is not defined at 0. Okay. So negative infinity to 0, see at 0, there is a bracket facing left and a parenthesis facing right. Exactly under 0, I will have these two symbols touching each other. Exactly how I see them here. A bracket opening to the left and the parenthesis opening to the right. Exactly under 0, not something like this. Right under 0. Okay. At 2, I only see a parenthesis facing left. I don't see anything else because the function is not defined here. And at 4, I see a bracket facing right. So this transformation from the inequalities to the interval notation serves two purposes. One, for determining the domain, and the second one, to determine the symbols under each number. Now I make myself a note, and be very careful. These pieces, these branches, are not always presented in the correct order from left to right. These are negative infinity 0, and then it follows 0, 2, and then follows 4 to infinity. But this branch could be first, and this could be last, just to mess us up, or try to. So at this point, I know that between negative infinity and 0, which of these three functions will I use?
The first one?
2, very good. Between 0 and 2, which one will I use? I know it's a silly question, but I want to see them here, so I don't make an error.
Negative x squared.
1 minus x squared. Good.
Oh, minus x squared.
And the other one, between 4 and infinity, obviously it has to be the last one. Perfect. At this point, nothing matters. Don't look anywhere. I'm talking about this first branch. I will pick some points. Let's say I'm going to pick negative 1. When x is negative 1, how much is y?
2.
Excellent. When x is 0, how much is y?
2.
Very good. Right here inside the bracket. Inside the bracket. I'm done with this side. I'm in the middle now. When x is 0, you see the parenthesis and you should say, no, you're not allowed to plug in 0. And I will have to say, yes, you're right. But if you don't allow me to plug in 0 and leave it open, then you will have to plug in 0.000000000000001, square it, and subtract it from 1 and tell me what to write. So let's plug in 0 and tell me what you get.
1.
Good. Inside the parenthesis. Good. On the other side, so this is a quadratic function. So at 2, to the left of 2, can you plug it in and tell me what to write inside?
2.
So we evaluate 1 minus x squared for 2.
Negative 3.
Negative 3 indeed. Good. We'll see if we need other points in there. We're done with these two branches. I'm here now. Please plug in 4 and tell me what you get.
3.
Good, indeed. 4 plus 5 is 9. The square root of 9 is 3. And let's find another number that is nice and beautiful. So I can take the square root from it. The next perfect square after 9 is 16.
16.
Good. So what should x be for getting the square root of 16?
11.
Very good. And the square root of 16 is
4.
4. I could have chosen any other number, but I just wanted to choose something nice. Okay, we're ready now. I will graph with 3 different colors so you understand that it will be a terrible mistake to show something like this. Impossible. Okay. So I'm going to use orange for the first branch. What is the first ordered pair that I have to plot?
-1 and 2.
Second ordered pair that I have to plot.
Zero and two.
Full point or open point?
Full.
Closed.
Very good, because of the bracket. Very good. So I'm graphing y equals 2. I'm done with orange. Let's say green. Red, green, let's say green. Next ordered pair.
0 and 1.
Full point or open?
Open.
Of course, it will not be a function. I'm exaggerating. It will not be a function if I were to make this full. Next one.
2 and -3.
2 and -3. Full stop, full point or open?
Open.
Excellent. This is a quadratic function with a maximum because the leading coefficient is negative. Finish with green. Good. Next. Next ordered pair.
4 and 3.
4 and 3. So 2, 3, 4, 3. Full point or open?
Full.
Very good. And whenever I get to 11, the graph of a square root function is this. Notice that orange, green, and black do not overlap. They have nothing in common. They cannot have common points.